begin the new topic, that is artificial satellites. Dear children, there are two types of satellites, natural satellite and artificial satellites. Natural satellite is an astronomical object orbiting the Earth or any other planet. Artificial satellite is a man-made object which revolves around the Earth or any other planet. The first artificial satellite was sent to space by Soviet Union in 1957 as shown in the figure. Today, more than thousands of artificial satellites are orbiting the Earth. The satellites work on solar energy. We know that it's a machine and machine needs the energy to move around. That's why in satellites there is an solar panel. This solar panel helps the satellites to get energy. Solar panels are attached to the satellites like wings on both the sides. Instruments are installed in the satellites to receive and transmit signals from and to the Earth. On the basis of their functions, satellites are classified into different types. One such satellite is shown in the figure. Signals transmitted from the Earth to the satellite and from satellite to the mobile tower and mobile phone are also shown in the picture. These satellites are sent into the space to perform various functions. Satellites are classified into different categories. Number 1. Weather satellite. Weather satellite helps to predict the weather parameters. For example, INSET and GSET. These are the names of Indian satellite series. Second is communication satellite. Communication satellite is established for communication and different locations in the world through the use of specific waves. The examples of Indian satellite series are INSET and GSET. Third is broadcast satellite. Broadcast satellite is used for telecasting of television programs. Fourth type is navigational satellites. Navigational satellites fix the location of any place on the Earth's surface in terms of its latitude and longitude. Military satellites. Military satellites collect information for security aspects. And last one is Earth observation satellites. Earth observation satellite is used to study forests, deserts, oceans, polar ice on the Earth's surface, exploration and management of natural resources, observation and guidance in case of natural calamities like earthquake. Let's begin the new topic, that is orbits of artificial satellites. Dear children, We know that artificial satellites do not revolve in similar orbits around the Earth. The function of satellite decide the height of the satellite's orbit from the Earth's surface. The nature of the orbit either circular or elliptical, and whether the orbit shall be parallel to equator or making some angle with it. To put the satellites in its specific orbit, satellite launching vehicles or satellite launches are introduced. The satellite is given a specific velocity known as critical velocity or VC in a tangential direction to the orbit. As shown in the figure, satellite starts revolving around the Earth. The formula for velocity can be derived as mass of satellite m is revolving around the Earth in an orbit of height h with the speed vc, then a centripetal force mvc square upon r will act on it. Here r is the orbital radius of the satellite from the center of the Earth. Centripetal force is equal to gravitational force between the Earth and satellite. mvc square upon capital R plus h is equal to capital G capital M small m upon R plus h bracket square. Therefore, Vc square is equal to Gm upon R plus h. So, Vc is equal to under root Gm upon R plus h. We know very well G is equal to gravitational constant and mass of the Earth, R radius of the Earth, h height of the satellite orbit above the Earth's surface, and R plus h, that is radius of the orbit of satellite. Depending on the height of the satellite's orbit above the Earth's surface, satellite orbit are classified as high Earth orbit, low Earth orbit, and medium Earth orbit. Let's see the first one, high Earth orbit. If the height of the satellite's orbit above the Earth's surface is greater than or equal to 35,780 km, the orbit is called high Earth orbit. A satellite revolving in an orbit above the Earth's surface will take around 24 hours to complete one revolution. We know that Earth also takes almost 24 hours for one revolution. If the satellite is revolving in an orbit parallel to the equator, the time of revolution from the Earth around itself and that for the satellite to revolve around the Earth being the same, the satellite will appear to be stationary with respect to the Earth. Second orbit, that is medium Earth orbit. If the height of the satellite orbit above the Earth's surface is in between 2000 km and 35,780 780 kilometers. The orbits are called medium Earth orbit. Geostationary satellites orbit above the equator. These are not useful in the study of polar regions. Third one is low Earth orbit. If the height of the satellite orbit above the Earth's surface is in between 180 km and 2000 km, the orbits are called low Earth orbits. The satellites used for scientific experiments and atmospheric studies revolving in low Earth orbit. Low Earth orbit satellites complete one revolution in around